Now let's move on and add some polynomials. Well, when we're talking about polynomials, we're basically just talking about terms, and poly means many, so many terms. So let's start off today. Let's go ahead and give us a polynomial. Let's go 3a plus 4b plus 2 minus a minus 2b plus 6 and plus 4a. That ought to be enough to start with. Okay, and yeah, we could have started out smaller, but I want you to understand a couple things here. All right, first off, every time we have a term, it's easy to separate those by adding and subtracting. All right, so realistically, we have 1, 2, 3, 4, 5, 6, 7 different terms as we look at those guys right now. When we say adding polynomials, all we're really saying is combining like terms. And that's what we're trying to do today. We're trying to make that thing look smaller, look easier, more appealing. All right? So when we do, we like to do this in a specific order. My specific order right now, I'm looking at A's. Why A's? Because that's first in the alphabet. So I will actually go through and I will make sure I have all my A's taken care of. When I do, I have 3 A's minus an A, which is 2A plus 4A, gets me 6 of those A's. Then next in the alphabet are my B's. And don't forget the signs. 4B. I have a minus 2b, and that seems to be all the b's that I have. So 4 minus 2 is plus 2b. And then I have my constants, and my constants all stay with each other as well. So I've got a 2 here and a 6 there, and 2 plus 6 is 8. And that is my answer. Now, please remember, for your sake and for the sake of your teacher, for sake of organization, this has an order. Please write that. An alphabet. I can't spell today, so let's try that again. Alphabetical order. Okay. Now, let's go ahead and try another one here real quick. Let me put this here. 6. Plus 4n squared minus 3n plus 7 minus, plus n. All right, now what you're going to notice is we can't put this guy in alphabetical order because the only letters of the alphabet we have are n. Please let me remind you, we cannot combine an n with an n squared. Okay? That's like combining a jack with a jack's son. It doesn't always go together. All right? They've got to be exactly the same or they just don't fit. So when we put these guys in order, we're actually going to go in exponential order. And typically, I like to do the highest exponential first. Now, as we go along in algebra, it doesn't always have to be this way. They can be in reverse order. They can be in 2 orders at the same time. We'll cross that bridge when we get to it. Okay? So for right now, highest exponential is first. So let's take a look at our highest exponential. Well, here's our highest exponential, 2. We also have a 4n squared. All right? And that looks to be like all of our n squared terms. So when we combine our n squared terms, we get a 6n squared. After n to the squared, the next exponential down is n to the first power. Well, there's an n to the first power, here's an n to the first power, and here's an n to the first power. And that guy, yes, is 1n. So when we look at these guys, we have a negative 4, a negative 3, and a positive 1, which negative 7 plus 1 is negative 6. And we have negative 6 of those n's. And last but not least are our constants. I have a positive 6 here and a positive 7 there, which does get us a positive 13. So if we're in letters of the alphabet, we go in alphabetical order. If we're in just one single letter, we have to pay attention to our exponents and go in exponential order. Now, let's go to our next. And let's subtract polynomials. And subtraction of polynomials is a little different. They'll even look a little bit different. So don't be scared of the way they look. They're going to do this to you. They're going to give you 4b. Let's go with that binomial. And then they're going to subtract this binomial from it. 4b. All right. Well, realistically, adding and subtracting are equal but opposite. But if we follow our orders of operations, as we can see in our first set of parentheses, there's nothing we can do. In our second set of parentheses, there's nothing we can do. But that subtraction sign in the middle actually means to distribute. And if you remember our rules for subtraction quite a while back, we used to say subtraction was adding the opposite sign. So a positive times a negative still equals a negative. So we still have that minus or negative sign out in front, but now we have to distribute it. So we can actually come out of those parentheses. The first set of parentheses, nothing really happened to. But now we have a negative times a 2a, and we get a negative 2a. We get a negative times a negative 4, and we get a positive 4b. And now we're right back to simply combining like terms. So really all that subtracting did was make us add the negative and then distribute that negative to every single term throughout our second set of parentheses. And now we're right back to, let me change out here a little bit because I can color code things a lot easier and make you see those a little bit better. 3a minus 2a is simply just a. I have a positive 4b and I have another positive 4b, which actually gets me plus 8 of those b's. So negative is not a huge deal. All right. So this next problem I'm going to do is a little bit of a increase in step, but I feel like if we just reference back to what we've done, all we're doing is a little bit longer problem. It's not that big of a deal. All right. So let's say we have 8m squared. We have plus 4m minus 7. Let's make that trinomial group. Then let's go ahead and subtract it from another trinomial, and we get 2m squared minus 5m plus 2. And we're going to take that, and I'm going to subtract another binomial from that, which is m squared plus m plus 1. And yes, right, we've got some length to this guy, some real girth to it. But really, if we break it down to our orders of operation, things seem to work together very nice, right? Because if we go into this first set of parentheses, there's nothing we can do with it. Sorry, I'm struggling a little bit. I dropped my pen. There's nothing we can do, so we can simply drop it out of there. We get 8m squared plus 4m minus 7. However, this second set of parentheses, this is add the opposite sign, so that negative has to be distributed to each and every one of those next terms, so we actually do get a minus 2m squared. Negative times that negative being distributed is a positive 5m, and a positive times that negative being distributed is a negative 2. And that keeps us in these brackets, right? And then everything else behind simply falls. We don't want to mess with it right now because we're doing parentheses as we get to them left to right. So now inside of our parentheses, now there's something we can do. Here's our m squared. Here's our m's. And here's our constants. So let's go ahead. And I have let's see here, that would have been 6m squared. That's plus my green circles, which is 9m's, and then my blue circles, which is minus 9. And you see how that all of a sudden we're getting very small very fast. Minus that m squared plus m plus 1. I'm sorry, I should have put my parentheses there to begin with, but there we have it, dropped down just exactly as she was before. And again, what you're going to see is this subtraction sign. So we're going to add the opposite sign, and that gets distributed to each and every term. So it actually comes out of there. And in our first set of parentheses, it comes out of there anyway, because there's nothing we can do now. Plus 9m minus 9. This would be minus m squared minus m minus 1. And we combine like terms. Here we go again. I've got my m squareds. I got my m squareds. Here's my m's and my constants, right? So we combine like terms here, and we get a 5m squared plus 8m, because when we're adding opposite signs, we find the difference, the sign of the larger, right? And then we go minus 10. And that huge long problem comes out to many multiple steps, but it's the same steps over and over and over. Hopefully that helps you add and subtract polynomials.